Bruce.
Okay. All right, everybody. Thank you for joining us and welcome to our webinar today. Today, the webinar is collecting quality data. And this is really important. In my view, both ends of the pipeline, let's call it for simplicity, both ends of the pipeline are very important and should be a core competency of every company that's deploying IoT. In this case, we're going to talk about the collection of data end. Now, before we start, we're at the top of the hour. Before we start, I want to make sure that everybody knows how to ask questions. And I also kind of want to make sure that you can hear us and you can see this. You can see our slides, because believe it or not, sadly, I have actually gone through an entire webinar with no one being able to hear or see the slides. So if you can, I see there's a whole bunch of you on now. If someone can just go to the chat window, and you'll see it in your client, there'll be an icon, and in there, just type out, yeah, I can hear you, and I can see you. That'll also be, if everyone wants to take a look, this will be the way that you'll ask questions. And you can feel free to ask questions at any time during the presentation. Thanks, Pierre. You can feel free to ask questions at any time during the presentation. And Jen may answer, so we have Jen in the background there. She may answer the questions directly, or we may hold off, and we're going to be doing the Q&A at the end of the webinar as well. Great, Stephen again, looks good. Hey, Stefan from Germany. So I guess I shouldn't just say good morning, I should say good afternoon, and I should also say good evening. So thanks again for everybody joining us. We've got a good crowd today. And I think we're going to get started. So I want to first just give everyone a high-level goal. Well, this is actually our goal, and we hope that we're going to be able to succeed in delivering the goal. It's pretty high level, but it's pretty important. And that is, we're hoping that by the end of this webinar, you're going to know how to create value at the edge. Because as I said, the edge, great, thanks, Antonio. The edge is where we're collecting our raw data, and then the other end is the analytics. And in between, this is where you have an IoT platform. And for me, this is where it's definitely a buy kind of decision, not a build kind of decision. However, at the edge, where you're collecting the data, and at the other end of the pipe, or say at the other edge, this is where you're interpreting the data. This is where you should be doing it yourself, because this has to be a core competency, because the data is so important and is very critical to creating value with IoT. Okay, so let's look at today's agenda. In today's webinar, I'm going to start things off with a short introduction. I'm going to look at IoT at a very high level, IoT value creation at a very high level. Then I'm going to pass it on to Dave Higgins. He's going to present collecting quality data, maximizing IoT value with custom, very important, custom edge solutions. And then he's going to show a short demo, and we'll get into the Q&A. Now, by the way, Dave is the VP of IoT at Benchmark Electronics. He's been in tech for more than 25 years. He started at IBM in coding and customer care, where he advanced to be the VP of Lenovo's PC and smart devices software organization. Dave joined Benchmark last year with the goal of greatly scaling up the IoT business. All right, so everyone knows we got the questions on the side. If you just came in, I see a bunch of people have just arrived in the webinar. There is a chat client, or in the client there's a chat location. Feel free to ask questions at any time, and as I said earlier, we'll answer them if it makes sense at the time, or we'll wait. And number 4 there, that's the part of the presentation we will answer any questions. Now, if you want Dave or me in particular to answer a question, if you remember, just put our name. Otherwise, I'll default to Dave in terms of answering the questions. And we'll stay here for as long as it takes and answer all of your questions. So I like to think about this. This is how that I work with my clients on defining defining my IoT deployment or defining their IoT deployment, whether it's a pilot or whether it's going to be a prototype. We start with the value. We think about what's the value that we're trying to create. Then, what's the information that we need to create that value? Then, what's the data we need to collect to create that information that we need to create that value? And only then do we start looking at the technology. And I'm going to go through this in a couple different examples, but that's the technology that we're talking about today. And in particular, it's going to be the technology of the sensing. So what's the data that we need? And then what's the technology that we need to collect that data, to create that information, to ultimately create that value? At a very high level, there are 4 ways to create value with IoT. We can make our products better. We can operate our products better. We can maintain our products better. And we can make new products better. Another way of saying this is innovation, operational efficiency, asset utilization, and invention. Now, the process, and I like to call this the value creation method or value modeling that I use, and I suggest that you maybe consider it, is that, again, we start at creating what's the value or identifying the value that we're trying to create. And then we're going to break it down in 2 ways. We're going to qualify that by creating a value statement, and then we're going to quantify that by creating a model. After that, we then look at, all right, well then, once we have that model, what's the data that the model needs? And that'll eventually tell us, in this particular situation, what's the sensors that we need and what's the embedded system that Dave will be talking about in great lengths. So I'm going to bring up an example of one of my clients, and they build custom lights. And these are fancy lights they sell to university campuses and small cities, I guess towns. And what they want to do, and this is, they're taking advantage of the switch from incandescent lighting to LED lighting, where there's great cost savings. Now, to do that, you're generally switching or changing the top of the light. And so this is a great opportunity to put more sensors in. But we need to first start with the value proposition. Now, also to be clear, there can be many different value propositions. In this case, we're going to look at one that's related to safety, and ultimately, actually, the value proposition that we came up with at the high level, or I should say the outcome, and then we have different value propositions that'll lead us to that outcome. But the outcome that we wanted with the lighting wasn't lighting, but it was safety. But one of those value propositions, to zoom in, is to maintain a constant light independent of its environment. So what I've done here is just created a very simple, and I qualified the value proposition. Next, we need to quantify the value proposition. Now, this is when we get into the technicalities of how the product or the pilot, this can be obviously a pilot or it can be a discrete product, would work. Now, this is more of an environment. And so there's a lot of physics involved that we can actually model mathematically so that we can ensure that our lighting does present an even constant light in the campus, to protect our students, or in the cities, small towns, to protect its citizens. So if we look at it, the first one was to qualify the value proposition. This is what I mean by quantifying the value proposition. So lux, this is a measurement of light intensity, and it's generally on a square. I think that's on a square centimeter basis. In this case, it's going to be a function of the location of the light network. So where are each of the lights geophysically? The beam angle, the LED color, the external light sources. So this is where we're going to need to be measuring whether there's headlights, whether there's other lights, whether there's other forms of illumination like the sky, for example, the time of year and the weather conditions. So as you can see now, by quantifying the value proposition, we've also unearthed or uncovered the variables that we need for our model. These are all the variables that we need to ensure that our sophisticated IoT light puts down that very constant and even light source. This is also the data that we need to collect from our sensors. Now, some of it will be from sensors, and some of it will be from external systems. So, for example, the location of the light network, that's going to come in from an external source, not a sensor. But the beam angle, that'll come in from a sensor. The LED color, again, that's going to be coming in from a source. Maybe it's just going to be a table. The external light sources, this will be coming in from other sensors. The time of year and the weather conditions, these will be coming in from external systems. But more the point here is that we started out with the value proposition. That's qualifying the value. We then quantified that value with this model. And then we start looking at what the other data points that we need or other requirements are requirements for application in our data science. So in the case of the application, we want to integrate that model with the sensors. We want to also be able to actuate the light device, so we can change the angle we can change the intensity depending on the external light. So the idea is that the lights don't just turn on. The idea for this particular product that we invented was that as the sun went down, the intensity of the light went up. And then we have various different analytics and machine learning techniques that we then apply to that data that we're collecting. So at a very high level, I just wanted to go through kind of at the very highest level how we're then getting to the point of what are the sensors we need, and then what's the embedded sensors that we need, what's the embedded technology that we need to support those sensors. Now this diagram may be very difficult to see, or maybe you can see it, but this is a dependency graph, and it shows you the dependencies of the various IoT technologies. In the case here, what we're doing is we're identifying the data that's going to define our digital twin, and that'll be then the sensors and the actuators will be dependent on that digital twin, and then below that the embedded system will be dependent on the sensors. And also you can see there's the dependency on the radio type, so what type of radio. These are going to be numerous things that Dave will be talking about in his presentation. Now we'll send you the presentation so you'll be able to take a closer look at this diagram. So with that, a very short intro, but trying to set the stage of, okay, now we know what we need in terms of our requirements. Now, how do we build that front end? How do we start collecting that data? Now, all incremental value from an IoT product comes from transforming its data into useful information. So that's what we're going to talk about today, is the collection part, and the transformation part on the other end of that pipeline, as I was talking about earlier, is going to be done with analytics or artificial intelligence. So Dave, I will pass this over to you.
Okay, thanks, Bruce. I really appreciate the great introduction. Let me see if I can get these slides going.
Yeah, I can help you out as well. Oops.
Got it. Okay. Just got to go back, I think. Okay, thank you. I just got to go back to the beginning for a second here.
This is a little preview, I guess, a little faster.
Yeah.
Okay.
All right. Thanks. Like Bruce said, my name's Dave Higgins, and I have the privilege of joining Benchmark in July of last year, July of 2017, and trying to take our IoT solutions group to the next level and building a very flexible IoT platform or set of technology building blocks, which I hope to talk to you about today. So here's a little bit about what we're going to go over. First, I'll try and give you an introduction of who is Benchmark and what do we do, what's our focus, talk a little bit about the challenge of creating the right sensor network, and then some of the choices you have to make and our recommendations on the approach. I want to talk to you a little bit about our rapid prototyping process. We find a lot of our clients are in a hurry to get value out of the solution. So we've come up with what we think is a very good methodology for how to move fast, how to get a rapid prototype of whatever it is you're trying to design. And like Bruce said, we're focused today on the collection of the data, and then on the front end, and then at the gateway and up in the cloud, you need to turn that data into information or insight that you can use to some good end. Talk about a couple of case studies that utilize our technology platform, and a little bit about some of the client situations we've been working on. And then want to give you a video of a demo of our solution and a demo of how you could use this kind of for the factory of the future, and then go into a Q&A and answer your questions. So let's get started. So first, who is Benchmark? So Benchmark is a large manufacturing organization, but we also have a large team of design services engineers, and we've invested a lot in some various technology solutions. So let me describe that. We have over 10 locations in our engineering and technology solutions, 4 countries, and well over 350 engineers. So we have our Minnesota operation, which has a lot of good background and history in the medical device field, and a lot of design services engineers, and that's in Winona, Rochester, and Arden Hills. We also have a team in Almelo, Netherlands, and again in design services, and they do an excellent job. And then we have various places where we've invested in technology solutions. So one we're going to talk to you about today, IoT solutions. Another one is in Santa Ana, California, which is our secure technology team. We do a lot of focus there on aerospace and defense. And then here in the Phoenix, Scottsdale area, we have Lark RF technology. We have an awful lot of people that are very good in the RF space. And something I'm going to mention a little bit about this liquid crystal polymer technology, which we're using to miniaturize a bunch of our clients' electronics. We've also invested in the surveillance area, and then also creating medical patches, really for biomedical sensors, I would call it. And then finally, we have our advanced technology team. They're always looking ahead, and then feeding back into the business units what they're finding and helping us get a head start on what technology is needed by our customers. So let me talk about a little bit about the challenge of developing the right sensor network and the collecting end of the data, where you collect the data at the edge, send it up through the gateway to the cloud, and then you have your artificial intelligence or machine learning operate on that data and turn your data into information or insight. So the first challenge is really when you design the system, you really need to do a thoughtful job of making sure you're collecting the right data. There's all kinds of statistics out there about people collecting data and then not doing anything with it. I call that kind of write-only memory, which doesn't make any sense, right? And then another challenge is choosing the right connectivity solution. And that really depends on your use case, but it requires a good amount of experience and expertise. So I think Bruce mentioned when you're collecting the data, that's something you really want to get some help with. And I think that also is true for when you're choosing what your connectivity solution is. And I'm going to talk about that a little bit in a few slides. And then getting everything to talk together and work together. Really, how do you customize the solution to make sure it's achieving the goals that you've set out when you kind of set out on this IoT journey? So let me tell you how we do it. We've set up in Benchmark some design centers of innovation, and IoT is one of those design centers of innovation. So if you look at the left-hand side of the chart, this usually starts with a creative workshop where we get the customer and our team together, our team of engineers together, and talk about what is the solution, what is the problem they're trying to solve. Then it goes into our design center of innovation where I mentioned our advanced technology team. They have a bunch of work that they've done to try and look at the technologies ahead of time. We have a bunch of third-party partnerships which we bring to the table. We have a set of very talented design engineers. And then we made some investments in some platforms or some technology building blocks that we bring to the table. And with that, we take the customer problem, these elements, and come up with our customer solution. So, and this has worked, extremely well for us, this approach. So let me talk about an IoT, what we're focused on. We're focused on, two main areas, and at the technology building block level, they're kind of similar. Asset management, which I'll define as we can tell you the location, condition, and environment of whatever it is you want to track. So it's more than So when I start to talk about asset management, a lot of people go to asset tracking, but I'm talking about more than that. Asset tracking is the location part, but then we can also send you the data along with the location. So some kind of sensor information about the environment or condition of the environment of that asset or person or whatever it is you want to track, or the condition through data. And then another way we've kind of tried to invest in our platform is by setting up an industrial sensor network. And that's very similar to the asset management, except it's usually when you don't care about the location. So in this picture, you got an example of oil wells or oil field where, you know, they're not going to move around on you. So really just collecting that sensor information, sending it up to the gateway, sending it up to the cloud, and then operating on it to come up with the information or insight that you want. But again, the underlying technologies for both of those focus areas is very, very similar. Just the one on the right, you don't care about the location so much. Okay, so this is another look at custom sensor networks in an IoT environment, and it's fairly simple. Really, on the sensor network side, what you're doing is for each one of these use cases or icons, you're really putting together your sensor, a radio, and a microcontroller that really gets the data, sends it up to a gateway, and then on up to the cloud. And then you can operate on that data either in the gateway or the cloud, right? Either place or both, right? And then on to the user. So pretty simple picture. And I think Bruce said we'll be sending this to you guys as well, if you like. All right, so let me talk a little bit about our, what I call our asset management, very flexible platform or set of technology building blocks, and how we've gone about building that. And really, we've done it so we can react quickly to the customer needs, because our customers want to go from their problem to the concept on the solution to a prototype pretty quickly. And with this solution, we can get there in about 60 days to prototype. And then you can customize it to come up with the real kind of purpose-optimized solution. So on the left, we have a board we call internally Ghost, and it's really, and I'm going to talk more about it in the next chart. But it's a very flexible board where we can have do our rapid prototyping in-house on our benchtop, right? And that's where for our internal engineers to work on it, understand the customer situation and problem, and then use this board to do a rapid prototype. Then we move to another board, which internally we call our Lady prototype. And on that one, it has really all the electronics on the first board, but a little bit smaller, and so that we can actually deploy it into the customer situation for a prototype. Then you get some feedback on your proof of concept, and then you move to production, where you really want to move to a more purpose-optimized solution, where you're thinking more about the size, the cost, the form factor, the battery, the size, that kind of thing. So let me talk more about that. So first on the development platform, and again, this is for very flexible asset management. So what we've been using is on this board is a Nordic 840 M4 processor. We happen to have a NUTX RTOS running on it. And I'm going to talk more about precision asset tracking indoors. And for that, we're using a UWB ultra wideband solution. We also have on here a GPS solution and an IMU kind of accelerometer solution. And then over there on the left, we have a bunch of 4 microelectronic clipboards. And here you can plug in different radios you want or different sensors you want. And then we have the software to run all this. We have NFC. We also, I don't think I mentioned, we have Bluetooth on this as well. So you can talk to other sensors as well. And this allows us to rapidly prototype a solution for our client, because we have all this set up ahead of time. And then we can move to a pilot. And again, this is a little bit smaller. It has all the electronics on it. It also has the ability to add a mezzanine board on it in case you want to add more sensors or more radios to it. And again, this has the microcontroller, ultra wideband radio. which we use for doing very precise asset location indoors through some ranging. Has Bluetooth, which we use to connect to various sensors that you might want. Has the GPS and has an IMU if you want to do some kind of inertial tracking or something like that. And then we're working, and I mentioned in the beginning, our LARC group that's part of our engineering services and solutions team, and they're here locally in the Phoenix area, and they're extremely good at miniaturization and using this technology called liquid crystal polymer technology. So we work hand in hand with them to take the solution that you saw on the previous pages and to shrink it down. And right now, we can shrink the electronics down to about the size of a quarter. We believe we can go below that. The team tells me we believe we can get down to the size of a dime. And then also through some pretty cool technology on this here, embedding the ultra wideband antenna in there as well. So that'll really shrink the solution and be very useful for that many more circumstances and use cases. So I think now I'll move into some use cases. So again, we have a very flexible platform or set of technology building blocks for asset management and industrial sensor networks for collecting your data, getting up to the gateway and the cloud. So here's one use case, kind of abstracted a little bit, for if you wanted to know, if you have sensitive assets that you need to pick up. So say you have assets get pushed into a box somewhere, and then you have a carrier come around at the end of the day. You can do that, and you can have the carrier go to all the boxes that you have out there, but then you really waste time when there's nothing in there. So we have a very simple solution using our platform that will know when have you opened the lid or the door of the box, have optical sensors in there. You could have some kind of sense weight as well, that something's in there, and then hook it in with a microcontroller, an LTE solution, and then just send a signal up to the cloud that, hey, there's something here, come get me. And then you can add on to that and make it more complex, but it's pretty simple. You just know when the door is open, you know when something's put in the box, you have your microcontroller and your LTE solution, and then send a message to the cloud, if something's here, come get me. And then you can also send to the cloud of, if you have batteries in the solution, whether you need the batteries replaced or not. So pretty simple application of the solution. And I think it goes back to what Bruce said in the beginning, is you really want to know, what's my goal here? What's my return on investment? And then approach your solution. So this is a solution for how do I get that data? And you can make it a little more complicated if you have other use cases you need. So also in the beginning, talked a little bit about choosing your connectivity solution is a very key part of the design. And what do you need to consider there? Really, you need to consider, what's my environment? What's the use case? Is it indoors, outdoors? On the left-hand axis, you can see it's really about the environment. On the horizontal axis, you can see that it's about how precise do I need to be. So we found for precision indoor asset tracking, we're using ultra wideband because it's very precise. It'll get you down to about 10 centimeters of accuracy. If you don't need that kind of precision, you can use Bluetooth or some other solution. If you're trying to track something outdoors, GPS is a good solution. So this is just one approach we have to look at, what is the use case? What do you need to do? How accurate does it need to be? And then there's other considerations as well, like cost and form factor and other considerations when making this decision. But it's a key decision. So talk about another use case we've worked on, where really safety and surveillance is a really big issue out there. So if you want to keep everybody in your stadium safe, you need the right lighting. You also need the right level of surveillance with various cameras, and really you can think of the cameras as sensors. And there's a lot that you can do there. We have partnerships with with where we're doing a lot to make sure we're understanding the camera information. Let me show you another picture here. So we kind of tie it all together using the cameras and real-time location services. Will give you an integrated view of the security in the stadium and potential threats. So it's all tied together in a command and control area. You can put this asset management or asset tracking solution on the security guards, so you know their location within the stadium. You can put sensors on them, so you know how are they doing, health and safety wise. Tie all the cameras together into the control center, and then really pull a tremendous amount of data together, and then act on it through the control center and make sure that your environment is safe. Because really, what you're doing is you're gaining insight, you're gaining information on what's going on there. Really kind of situational awareness. So we're using our platform for this solution today. Here's one more that we've talked about. It's also fairly simple. Say you want to transport a heart for transplant surgery. So really, you can use the solution for you could use a GPS solution for GPS radio for tracking outdoors, microcontroller, LTE. You can also put a bunch of sensors in there. What's the vibration that the container went through? What's the temperature? So again, a pretty simple application for an interesting use case. And then we're going to show you a demo of our platform in action. But you can also use this platform and solutions for, how can we maximize the productivity of employees in a factory? So you could see how you can track the employees around the factory. You could make sure that they're safe by having various sensors on them or in the environment and sending that up through the gateway to the cloud. You could track the location of various high-value assets around the factory. You could track the condition of a lot of the equipment, how's that doing, and then just kind of blending that all together up through the gateway, up to the cloud, and allow you to run your factory more safely and in a more productive manner. So I think with that, we'll go over to the video. So let me go back one.
Hi, I'm Jake, and these are my colleagues, Jennifer and Kylie. What we'll be doing today is showing you a demo. I work for the IoT division of Benchmark, and this is going to be a location plus sensing demo. All right. What we have here is Benchmark has a rapid prototyping platform, which we have our custom hardware and software running on, and we can do many different things. In this case, this device tracks your location using ultra wideband, and this device is tracking your heart rate or your temperature and sending it over Bluetooth to this ultra wideband tag, and then sending all that data to a centralized location to go to the gateway and off to the cloud. The way the location works is there are anchors like this spread around the room, 3 of them, and we're going to be triangulating that based on these known locations. So Jennifer and Kylie, can you walk around? And then if you look at the GUI, there is a white circle in the middle that is a geofence. And we're going to show you that we can trigger off of certain thresholds. There you go. Kylie just walked into the geofence, and we got an event notification. And when she walks out, we got an event notification. Same thing when Jennifer walks in. So what that shows you is you can trigger on different thresholds. So a geofence, or if their heart rate went too high, you could also trigger on that. So thank you for watching our demo.
Okay. All right, Dave, why don't you take it from here?
Okay, thanks. So I hope that that demo kind of got across part of our solution with asset management. So Jake showed that really we have those trackers, and those trackers are using ultra wideband. So there's 3 anchors around, and they're all doing ranging to very precisely tell you where they are. And you can imagine putting them on people or equipment. So say you're in a hospital and you have some high value equipment that you want to find out where is it, and say you have 5 of these pieces of equipment, and people are telling you that we need to order 5 more, right? So maybe you do need 5 more, maybe you need 10, or maybe you just need to be able to find them a little more easily, and not just locate them, but tell you what's the condition, what's the battery on the equipment, what's the location, whatever else you want to know about it. And say you want to do it in such a way that you can bring it up on your smartphone and say, hey, I need one of these pieces of equipment. Where is it? And you can find it real quickly, see the environment, and go out and get it, kind of thing. And then you could track how often is it being used, and do I really need 10 of them, or is 5 sufficient? Another part of that video I wanted to emphasize is most of it centered around the location, but Jake also mentioned the heart rate patch. So again, it's asset management, not asset tracking. So it's the location, condition, and environment. So in this case, you could be tracking the person with the heart rate sensor, with the heart rate and the temperature, or whatever it is you wanted to. Say you're in a dangerous mine or something like that, and you wanted to track some kind of dangerous chemical and know that could affect your people, right? So really, the examples are limitless of where you can use this. And the use cases, but the base technology is really you can reuse the technology and the building blocks. We've tried to build it in a very flexible way so we can apply it. What we found in working with our customers is we're not finding situations where one size fits all, where you can just go and roll in there and say, boom, here's your solution. We're finding a lot of situations where you can use the technology building blocks, the platform, to have 80% of the solutions, but we're finding where we need to go in there and tailor or customize it to really solve the customer problem. And I think that's where some of these implementations may go wrong in people's expectation of what needs to happen. So now I think, Bruce, we move to the Q&A, right?
Yeah, and actually, I have a question to start things off. You don't have to be exact, but I'm sure a lot of people are wondering, how much is all this? Like for me, for example, we could have used that exact solution. I didn't know about it, but I could have used it with a manufacturing client of mine, because we were actually tracking the people, and we were tracking the people rather than the machines. So we're trying to do operational efficiency by looking at which team member. It was actually access control originally, where that was where the problem started. But then, can you give us just some, generally speaking, what type of costs are we talking about for, just roughly, for prototyping, and then when we start getting the scale? And I'm most interested in this, in your tracking solution, that very highly accurate tracking solution.
So it's a difficult question because it really depends on, so you narrowed it down. So if you want to do the indoor, very accurate tracking, that narrows it down some. But now you need to figure out, what's my battery life? How rugged does it need to be? What sensors do I need to put on it, right? So it's really hard to say. We really need a more specific example to put it together. And then you need to fold in there, what level of customization do you need? So there's multiple components of it. There's the tags, right? Which, you could get the tags either in the $50 or $100 range, in general. If you have a pretty good battery on them, you want to do very accurate tracking. Now you can do cheaper solutions. You could do a Bluetooth solution if the accuracy is not as important, right? But if you really need accuracy, the ultra wideband's probably the best, is what we found. But it really depends. And then how much customization do you need? So,
But roughly speaking, like if for a prototype, let's say, we're talking about $1,000 investment, a $5,000 investment, just to get that the demo that you were demonstrating working.
uh, so we've invested quite a bit to get that working because we have that demo working. We have all the software and the platforms and all that. So
Yeah,
uh,
I just mean like kind of that sort of thing. I just want to get an order of
so
magnitude here.
I think for the tags, you'd be looking at probably a $50 range for the tags for each tag.
And then for the sensing base station or whatever you call it.
I'm not sure by what you mean by the sensing base station.
Well, is the tag what's on the person? I guess that's how I'm interpreting it, and then something has to sense those tags.
Yeah, the tag is the location, right? And then then probably the anchors, right? So maybe another $100 each anchor, right?
Okay.
But then
so
you have the sensor. What sensor
spec-
do you want to tie in with it? Do you want some kind of chemical sensor? Do you want some kind of
Sure.
light sensor? Do you want?
No, but you're in the hundreds of dollars.
Yeah, I
which,
think so.
which
Right.
is yeah, which is a lot less than what I thought.
Yeah.
Okay, so then let's take a few questions that have come up. And Jen, I think have you highlighted all the ones? Let's see here, just going through it, see which ones we didn't answer here. Okay, what kind of air secure firmware update management mechanism? So I think Kamu Air. I totally wrecked that. I think he's asking about over-the-air update mechanism. So what kind of over-the-air secure firmware update management mechanism do you use to ensure robust firmware updates in a secure fashion?
Right. So that's a great question. We haven't implemented that yet. We know it's important. We need to know that we need to update the over-the-air updates in a very secure way. So we've had somebody play around with it a little bit, but we haven't implemented that in the platform yet. But we know it's important, and we know we need to.
Now, is there an over-the-air mechanism that's not secure, or are you referring strictly to, say, encrypting it or something like that?
So I think you really need to make sure that it's secure, that that you're doing the right level of provisioning to each one of these tags or assets, and that you're really just doing it in a secure way.
Carl Ford, he has a question. He says, Dave, talk about battery power and power when you get a chance in general.
Okay, all right. So the battery power is important. One thing we really still need to do is really on the battery management. So one really thing you want to do is battery management is very, very key, right? So the battery technology is key, and then battery management. So you want to do things like if on your tag, that's why we have the IMU there, or kind of an accelerometer, so that you don't want to keep transmitting. If your asset stopped moving, you don't want to keep ranging and keep transmitting. You can just sit quietly and not be using.
That's a great idea. Yeah.
So that's really where you need to focus on the battery life, is on your power management. And again, we still have some work to do there, but we have that's where we have the IMU on our platform solution, right? So very, very key. Because also, if you have workers, right, you can't have the thing running down after 4 hours. You need it to work at least 24 hours so they can get to the end of their shift and charge it. So.
Okay, so that's what I was going to ask you. So roughly speaking, I mean, that's the goal for the demonstration that you showed, where you're tracking the asset. The goal would be at a minimum 24 hours, because the best practice would be then at the end of the shift, I guess at the end of the shift, then they would charge everything. Is that right? Yes.
Yeah. At least get the 24 hours in there so then they can charge it. Even better would be is if you design it for a week, right? So they just charge it over the weekend, but at a minimum daily. Not unlike your cell phone. If it doesn't work all day, then you got a problem.
How is the charging? Maybe this is a naive question, but how is the charging done? Is this you have to? How is it done?
So for this demo, we just charge it with a USB cable into each one of those tags. Is the way we're doing the demo. So. Okay.
And are there faster mechanisms, because the amperage isn't so great there, or is that pretty much the way to do it?
That's the way we've done it. So it's pretty simple.
All right. Anthony Very, he has a question for you. Dave, can you speak about the range of the anchors and the anchors mesh? How many anchors can connect to one gateway?
So the range, some people say it's up to 300 meters, but we found really in practice, 100 meters is a better metric. And also it needs to be line of sight. So you need to consider that if you're in a warehouse, you have pretty good line of sight, but you need to consider how many walls do you have in the way and that kind of thing. So that's key.
That's the range. So around 100 meters, did you say?
Yes, from the anchor to the tag, right?
Right, that's huge. That's like a football field or a soccer field.
It is, but then remember, line of sight is important there, right? So if you have a lot of things in a way, right? Now there's ways to get around that, where you can implement some kind of mesh where you're really hopping from tag to tag to tag to anchor. So there are things you can do there. And then there's also other things you can add to it, like inertial, right? So you can get some assist with tracking the inertial data as well and fusing that together. So.
Okay, yeah, no, that was the second part of Anthony's question about a mesh, and so you can extend it that way. And then his third part was how many anchors can connect to one gateway?
So I'll have to get back to. I don't know the answer to that. So.
Okay, then Anthony, we'll contact you directly on that one. Carl has another question here. Can you talk about how you manage the edge? Is there an actuator aspect to your abilities? Those seems like two, maybe Carl, if we're not getting it right, you can add some more color, but it seems like almost two questions. But how do you manage the edge? And is there an actuator component to this? Are you doing actuation also, or can you do actuation?
We have not, but we can, right? So that's really, kind of the extension. So you can, I just think of it as, going upstream and back downstream, right? So upstream, you can collect the data, send it to the gateway, to the cloud, turn your data to information and insight, and then you can have the actuator going down to, now let me affect some change in the environment to really automate something. So we have not done that. We have the ability to do that, and it's the logical extension, but we have not done that. But
okay.
But we have that capability, and that makes a lot of sense where now I'm pulling the data up to the cloud, I'm making some decisions, or in the gateway, and now I'm acting on that. And I can think of a couple use cases and a couple customer situations where they're not quite ready for it, but that's where they're going.
Okay. And Carl, yeah, if you need more details, just give us some more clarification in the chat window. And I'm going to skip your next question because I need you to add more detail, because the question was, who owns the intellectual property? You got to give us a little bit more on that. Next, we're going to go to Annie Hunt, and she says, can you speak more about the edge? Are there use cases where if the customer did not want data going to the cloud, that you could build applications right on the edge? So doing some edge computing, I think, is what Annie's talking about.
Yeah, yes, you can, right? So if you don't want to go to the cloud, you could do a couple things. You could set up an internal cloud, your internal server network, or you can have the operations done at the gateway, or a combination of both, right? Where you're having the operations done at the gateway, and really you need to figure out, what am I trying to accomplish and where, and then that'll help you figure out how powerful of a gateway do I need. But you can operate on it there, or up in the cloud, or on my internal servers.
Right. I mean, effectively anywhere on the network fabric is what you're saying.
Right.
And then depending on what type of horsepower you need, if it's a simple security mechanism, and I guess that would be analytics as well, or a security mechanism, then you might be able to use, some relatively low-powered MCUs. However, if you're doing any type of real analytics and maybe even doing some inference on AI, are there different levels of, I suppose this would be MCUs, and are there different levels of MCUs that you choose from depending on the workload? And how do you actually come up with that? Like, okay, this workload means you need this MCU versus this MCU, or is this kind of just done by experience and just kind of what you guys know?
It's really, if you go back to, I don't know if we can go back in the charts at all, but
Yeah, you can go back.
really, really comes down to what problem am I trying to solve and doing the design, right? So it kind of starts with that client interaction, that customer discussion, and where we talked about our design center of innovation, right? So it starts with the creative workshop, right? If we'll do a 2-3 day workshop with the customer and understanding, what are the goals, what are they trying to accomplish, and then you go and you write, this is your standard development, right? Your product requirements definition. What do I need to accomplish? And then you move into your spec and what are the needs, and then your prototype, your betas, etc. So it's all part of any good engineering process, right?
Okay, and Annie, you can ask for more clarification, but my follow-on question to that would be, what percentage of your IoT clients are rolling their own, so to speak, and choosing the components versus having you engage with them to do this 2 or 3 day workshop, or is that a requirement?
I think it really is a requirement, unless you really need to do that workshop, unless the client comes to you and says, hey, I have this 20-page products requirements definition, right? So we get both. I'm not sure of the percentage, but we get both, and not just IoT, but in our design services practice, right? We get customers that come with a very good document of here's what I want built, right? And then we have others that come with, hey, I have these ideas. And if that's the extent of what they have, then this creative workshop makes a lot of sense. And then also we engage our team with the customer team to write that initial document of really defining the what is it we need to build, and what problem are we trying to solve.
Okay, and again, just to push you a little bit more, is it over half have the requirements figured out, or is it less than half that have the requirements figured out?
I'd say over half have the requirements figured out from what needs to be built, right?
Okay.
Yeah, from what needs to be built. And then,
so you're implying that a majority are still having to go through this workshop with you to kind of get down to the details?
I think at least half have the requirements figured out from a product requirements definition. And then you can take it to the next level and go to what's my engineering spec, right, of the details, and then we find working directly with the customers, best there, figuring out together.
And is the business model for that a time and materials, or do you have packages? How, just for people that are actually budgeting for this, how do they plan for that? Because it sounds like this workshop is relatively necessary.
So we can do either. We can do time and materials, or once we understand the scope of what's needed, we can do kind of a phased approach or a fixed approach, right, with the quote. So, but we can do either way. So.
Okay. Again, Annie, if you need a little bit more detail, just ask again. The next question is from Lee Glidden, and he asks, or she, I think it's a he, what's the impact on the transmission solution if the data quantities are large and the data is complex or disparate? So I guess he's just looking for some rough guidelines. So what's the impact on the transmission solution if the data quantities are large and the data is complex or disparate?
Right. So that's just another axis on this chart, right? So it's a good point. Sorry, it takes a little bit to get there. But that's just another axis on, how much data am I going to try and send up, and what's the bandwidth, and what's the best solution for that. So that's just another axis, right? So you have the resolution, the accuracy, you have the use case, you have the cost, the form factor, and really the bandwidth that I'm trying to get through, right?
But at a high level, the impact is the greater the data quantities. And I don't know about complexity, but you tell me. But at least the greater the data quantities, I'm assuming the impact is going to be more horsepower and whatever that means, right? You're going to need to get a more robust type solution.
Right, more horsepower, more network bandwidth, right? More focus on the topology of the network, kind of thing. So,
okay, Lee, again, ask a follow-on if we didn't quite nail it for you. Next up, James Steele, can you address applications in medical environments where there could be a HIPAA compliance requirement?
Yeah. So again, back to our team. In the beginning, our Minnesota team has a lot of experience in the medical device field working with their customers. So the different members of our team have different experience, but the Minnesota team does have a lot of experience with HIPAA, FDA, that kind of thing, and a long heritage of working with medical devices. So I'm not an expert there, but we have experts in Rochester that do that.
Okay. All right. So James, you're going to have our email. If you have any, more detailed, if you want a detailed more follow-up, or if you have a detailed more question to follow up, we'll be happy to answer that. I'm going to go back to an earlier question from Carl, and that was the one I asked him to add a little bit more detail. And he said, talk about who owns intellectual property, please. And Jen answered it. Well, did Jen answer it? Yeah. So who owns it if they work? Who owns the intellectual property if a company engages Benchmark for a project like some of the ones that you've been talking about?
So it changes. It depends on the agreement, but in general, our customers hire our design services team and pay for that engineering and development. So then those customers own that intellectual property in general. There's exceptions to that, but in general, that's the, I'll call it 80% case. And then in other circumstances where we've already done a platform investment or a technology investment, and we have some existing capability or existing IP, we will license that to the customer. But in general, when the customer pays for the engineering, they own the intellectual property.
So to clarify, what you're saying is if there's custom engineering work that has to happen, then it's a negotiation, because you may want to use that custom work for other customers. Am I understanding that correctly?
That can be one option, but in general, if the customer is paying for the engineering, they want to own that intellectual property. But you can set it up so that it depends on if we already have a lot of the intellectual property and we're bringing it to the table, then we'll need to give the customer a license to that technology. But in general, the way the engineering services work is, if they're paying for it, they want to own that intellectual property. Yeah,
no, that makes sense, and I definitely would as well. We have another question from Carl, and then I know, Jen, you've got another one that you prompted me that you want to ask about WiMAX, but how many times have you been brought in after a POC? So Carl, you can add some more I guess color to that, but I think what you mean is the customers tried to do this on their own, and then they need to bring you in afterward. Is this something that's common, Dave, or not?
Yeah, it does happen, and it's not necessarily a bad thing. So customers, in fact, just working with a customer this week that has a very, very cool, very sophisticated proof of concept. They proved the concept, and now with a very small team, and now they want help making it a more robust solution. So some of the components and the technologies they chose are not right for a production environment, but they were just great for proving out the concept. So that does happen. I'm not sure what percentage, but that does happen, and there's nothing wrong with that. So it also, sometimes if they're startups, helps them for their investors, where they create a proof of concept, they can show it to their investors, but now they need more help to make it a more production, more robust solution.
No, and you bring up a very important point, and that is, I just call it to scale. But in particular, getting to a POC is one thing, getting to scale is another. At a very high level, what are the considerations that need to be considered to go from, like a test lab with, just like you had, a few sensors set up, to something that's really going to be scaled at a large level? What are the considerations that must be thought of?
So we talked about a few of them. So one, you need to be able to do the over-the-air updates. You need to be able to service your product. It needs to be more robust. You need to be able to manufacture it in a cost-effective way. So if you're going to create a POC, you're not really worried about that. But if you're going to create a real product, you need to be designing it for manufacturability, for serviceability. You want to design it in such a way that it doesn't take a tremendous amount of time to fabricate and manufacture, so you can be more efficient. There's a lot that needs to be considered, but doing that POC, if you can do it rapidly, if you could do it in a 60-day period, and proving out the concept does make a lot of sense. But you may need to realize that it's not a throwaway, but for the production design, you may need to start over, right? Depending on how you built it, if that makes sense to you.
Well, it does make sense, and I can say from my experience, generally, unless they would work with you from the very beginning, but generally it would be a throwaway. That's
right.
what I've seen, and then they come back, and maybe that's more what Carl was getting at, was okay, we've done it, now what? Because unless you're thinking about these issues and you're going in, like you mentioned the different factors, then often there's two different purposes. One is to get funding, a budget to be able to take that to scale, and the other one is to be able to get in production. Two different budgets going to come from two different areas, and often the POC is thrown out. Do you consider that a best practice, to just more or less get it done, and then, okay, once you get the funding, then let's get really serious about it? Or is it better to really be thinking about scale right from the very beginning, and taking it that way?
Yeah, I think a POC is valuable, but you don't want to confuse a POC with an alpha, right? So I would think of a POC as, I want to prove out the concept, I want to prove out the value, and then depending on your audience, you're sometimes if you want to just go show somebody your concept with a bunch of PowerPoint charts, right? It's hard to get their vision and get them to understand what you're doing, but a POC really brings it home. So that makes a lot of sense. But don't confuse it with an alpha, where I would say an alpha, you're building from, you're designing it from the beginning of, here's my requirements definition, here's my concept, here's my alpha, and you're building up, I'm going from alpha to beta to production, and you're building it with design for manufacturing from the beginning. So I think it's a very useful practice, as long as you don't confuse it with the production path, and you're using it for the purpose you should be using it for. I want to make sure people really get the concept I'm trying to show, so I'm going to do a quick 60-day, 90-day POC to get it across to them, or if you're a startup, potentially for the funding, that kind of thing.
Now, if they go that route, which is what I've seen, are they able to do that with your kit, with your gear as well, or are they doing it with some off the shelf like a Raspberry Pi or something? Then they come to you only when they really need to go to that scale and get real production quality.
Yeah, we don't have a lot of people coming to us just for the POC, where that's the end goal, right? Anybody who's coming to us is coming to us for, they want production, their scale. Now they may want a POC as a part of that process, which we can do, but they're not coming to us with that being the end goal. Right?
Okay, no, that makes sense. The question that Jennifer brought up was UWB, so ultra wideband. So you never hear about, you very rarely hear about ultra wideband. So why do you use that? Why would someone consider ultra wideband?
Really and it's and we're not married to it, right? But really, it's for the use case. If it's indoor, highly precise tracking that you want, it's a very good solution, right? If you want to track outdoor, GPS is a good solution. If you want to track indoor and you don't need the accuracy, maybe Bluetooth might be a good solution, right? So it really depends on what you're trying to do, and saying, hey, what's the accuracy? What's the cost? What's the battery? That kind of thing. So, and that's a lot of times why people need the experts, because you really got to study, what am I trying to accomplish? And then how do I design around it? Kind of form follows function. So
ultra wideband makes sense to me from an accuracy perspective. I think I know the answer, but I'll ask it out loud. What's its battery or energy requirements versus, let's say, Bluetooth maybe isn't a good. Wi-Fi. Let's say compared to Wi-Fi, is it in that range or is it more in the Bluetooth range?
I'm not sure. I could get back to you on that. So I don't know the answer.
No, this is just, no one's asked this, but it's just something that I'm curious about. I mean, Wi-Fi, with the higher accuracy, if you just look at the physics of the waveform, you're having to put out more energy, and that's why generally Wi-Fi isn't a battery operated. It's generally plugged into the wall. Ultra WiMAX Bluetooth is the opposite, where it's generally not plugged into the wall. It's battery powered. And that was what I don't have as
right.
much.
UWB for our solution the trackers will be battery powered. So.
Okay. We had a lot more questions than I anticipated, which is good because I think you anticipated it. I don't see any other questions. If there's any other questions that have come online, Jen, maybe let us know, or there's still a whole bunch of people online here. If there's any other questions you may have, put it in the chat window. Of course, you can see on our last slide here that you can do it yourself, and you can go to bench.com/IoT to just do a general investigation. But also, if you have particular questions that we didn't answer fully, or that you prefer just to ask individually, then feel free to email Dave and team at iot@bench.com. That's a great email address, and they'll be happy to answer any questions. Okay, well, I am looking and I'm not seeing any more questions. We've had a lot. I think then we're going to end the webinar. So thank you everyone for taking an hour out of your day, whether that was in the morning, the afternoon, or the evening. We really appreciate you being here with us. Again, you will get a follow-up email for those of you that have attended, and then it'll be up to the team, if everyone who just signed up will get it as well. And you'll get I can speak for myself, you'll get my presentation. And with that, thanks, Dave. Great presentation, or great perspective. You can see there's a lot of interest in this. Yep. And as I'll just conclude, it's super important. The middle part, the platform, rent it. That's fine. You don't need to understand it to the point where you build it yourself. This is something that you can buy as opposed to build. But on the two ends, that being the analytics on one end, which of course we didn't talk about, or we didn't talk about that much today, but on the data capture, super important, very important in terms of being able to understand this. It has to be part of your core competency in any IoT deployment. So thank you again, and we'll hopefully see you next time around.
All right. Thank you, Bruce. Appreciate it.